Hi there, it's Professor McDonald, and in this video, I'll be introducing the first part of Lesson 2, Sampling Methods, which is from Chapter 1 in the textbook, Sections 1.1 and 1.2. Lesson 2 has been titled Sampling Methods because that's the main portion of what we will be learning in this lesson, but there is a lot more to it. First of all, we want to get a sense of what statistics is, why it exists as a science. Since you are taking this class, what would be the motivation for learning statistics? We live in a society where important decisions are made by popular opinion, and reliable estimates are worth a lot of money. It is often not practical to collect data for an entire population. For example, the US Census costs $13 billion to complete. That's why we only do it every 10 years. In most situations, sampling methods are used. For this lesson, the learning objectives are to learn the basic terminology used in the study of statistics, differentiate between population parameters and sample statistics, determine whether data is qualitative, quantitative, and if it's quantitative, is it discrete or continuous? Determine the level of measurement for a set of data, nominal, ordinal, interval, or ratio. Identify the 5 common sampling methods: cluster, convenience, random, stratified, and systematic. This lesson aligns with the following course learning outcomes: defining population and sample. So here we will begin Part 1, Introduction to Statistics, where we learn some basic terminology and concepts to get us started in the world of statistics. Remember that this is a video, so you can pause and back up anytime you feel like things start moving a little too fast or you want to review a concept. If you'd like to have an opportunity of becoming very excited about statistics, this video is a great way to learn all the cool things you can do with statistical graphs. In this video, the professor is using Gapminder, and it makes very interactive and interesting presentation of data. This is by Hans Gosling. In section 1.1, we begin with definitions of statistics, probability, and key terms. First of all, what is the science of statistics? It deals with the collection, analysis, interpretation, and presentation of data. We see and use data in our everyday lives. It's a very interesting topic and subject area to delve into. There are 2 main areas of statistics. The first is descriptive or summary statistics, which is the process of organizing and summarizing data. Once you have collected information, you want to get a feel for what it looks like or how it behaves or what it means in general. Inferential statistics are formal methods using probability to determine how confident we can be that our conclusions are correct. So we start by describing a set of data, but then we would like to use that sample data to possibly infer something about the population that we're interested in learning about. Since we'll be using probability for inferential statistics, we should know what the definition is. Here we say it is a mathematical tool used to study randomness. It deals with the chance, the likelihood of an event occurring. So because we will need probability for inferential statistics, we will first learn about descriptive statistics, then about probabilities, and then go ahead and apply those concepts in inferential statistics. Some key terms here that we'll start off with that we should really be aware of and understand what they mean, since we'll be seeing them a lot, is the word variable. Variable, you may have heard it before, say in an algebra course, and you were probably taught that a variable is an unknown. And that's true here as well. But another way of describing a variable is that it's a question that we're interested in learning about a population. Variables may be numerical, which means quantitative, numbers that have quantities of meaning that is a quantity. So for instance, Social Security numbers are numbers, but they're not numerical in the sense that they don't represent quantities. Then we also have categorical data. We also call this qualitative because it's recording a quality from the population. The word data is used a lot. These are the actual values of the variable. In other words, the answers that you might receive to the question that represents the variable. They may be numbers or words, and the word datum is the singular version of data. So data means a whole set of values, and datum is one particular value. It's very important to know the difference between population parameters and sample statistics. First of all, we should know what a population is and what a sample is. A population is all of the members of a collection of persons, things, or objects under study. A sample is some of the members of a population. As we discussed earlier, it's difficult sometimes to get the answers from every individual in the population, so we draw a subset, a sample, that we strive to make as representative of the entire population as possible, and then we use the sample to infer something about the population. So what is a parameter? A parameter is a descriptive value which summarizes some characteristic of the population. This could be something like an average or a proportion. A statistic is a descriptive value which summarizes some characteristic of the sample. So notice that they are the same as far as the definition goes until you get to the last word. Parameter or parameter represents the population, and statistic represents a sample. Two words that come up often in statistics are mean and proportion. The mean is commonly known as the average, and it can only be calculated from quantities. So you've heard of an average, most likely, almost everyone has, and we say average in everyday life, but as a statistician, you will use the word mean because there are other measures of center in statistics that could be considered a type of average. So the mean is very specific. For example, if you were to take 3 exams with scores 86, 75, and 92, to calculate your mean score, you would add the 3 exam scores together as a total sum, then divide by how many exams you had to get your mean score. A proportion can be calculated for any kind of data, not just quantitative, and it's commonly used to represent qualitative data. For example, if your math class has 22 students who are men and 18 students are women, then assuming that's all the students in the class, we would have 40 students as a total. The proportion of men would be 22 divided by 40, or as a reduced fraction, 11 over 20, or as a decimal, 0.55, or as a percentage, 55%. Likewise, the proportion of women is 18 over 40, 9 over 20, 0.45, or 45%. That concludes the first part of Lesson 2. In the next video, we'll cover types of data. See you there.